Alright, this question is pretty obvious when you look at it in terms of, oh, now I know what I need to do. If it ever asks you to show that there's a root of an equation on an interval, you're always going to follow this procedure. You're going to declare, oh that's let. You're going to declare a function to be the left side minus the right side. What I mean by that is take this equation and turn it into one where one side of it is 0. So now this f of x would be 0 wherever there's a root of this function. See, I just flipped the sign of the thing that was on the right. Here's what you do. You plug in your left bound for x. In this case, I get -2 cubed plus -2 squared plus 2. And you plug in your right bound, -1 cubed plus -1 squared plus 2. When you evaluate these, you end up with -16 plus 4 plus 2. I get -10 over there. And I get -2 plus 1 plus 2. And I got 1 over here. The key is that one of these is positive and one of these is negative. What that means is, since f at -2 is less than 0 and f of -1 is greater than 0 and f is continuous on this interval, and you know it's continuous because it's just a regular polynomial, then there's something called the intermediate value theorem, which states that if you have a continuous function that's negative in one place and positive in another, then at some point in between those two, it must be exactly 0. Or you'll get 0 out for some value of a in between those two values. And that's exactly what we were looking to show here. Beautiful. It's as easy when they ask you to prove that there's a root as creating a function that equals 0 wherever the roots are, plugging in one of the values, plugging in the other value, making sure one's positive and negative, and then citing the intermediate value theorem to say, hey, if it's negative here and positive there, it's got to be 0 somewhere in there, and therefore, by extension, this has a root. Boom! Best of luck.